Okay, so we're going to look at here is the topic work, okay, or the heading work. So the first thing we're looking at here is show the equation being used for the following examples. Draw a diagram, write the question formula working, and A has already been done for you. So in a boy pushed a ball up a ramp. Okay, so imagine there's a ball here and we're going up a ramp. Okay, as it gets to the top, it gains gravitational potential energy. Okay, so I should write that more clearly. It didn't have it at the start. Okay, it didn't have any gravitational potential energy, and then it gains gravitational potential energy. And for it to do that, it needs to have work done on it. Okay, so this man that's pushing it, or the boy in this case, as the boy pushes it up the slope with a force over a certain distance, the ball will gain that much work, okay, or gain that much gravitational potential energy because work has been done on it. How do we calculate it? Well, we do the formula, W equals F times D, and then we put in 400 times 6, and we get 2,400 joules. Okay. And then after that, we do II. How much gravitational potential energy has it gained? So the work done on it is the gravitational potential energy gained, so that's 2,400. But all you do with blue text, remember, with blue text, you just copy it. For the next one down here, okay, now you've got to do your own thing. Okay, calculate the work done when you write this in. So you write your name, pushes a cart with a 600 Newton force for 100 meters horizontally against frictional forces. So work equals force times distance. So that's going to equal to 600 times 100, and you get 640. So that's 60,000 joules. Next one, what is the work done? So we're looking for W. When a car traveling with kinetic energy of that, so there's the kinetic energy, stops. So in other words, there's a car and it has 10,000 joules of energy, and when it stops, it will have 0 joules. So it's moving here and then it stops. It has this much change in energy. So the work is how much energy changed from there to there. Okay, so the answer is just equal to 10,000 joules because that is the amount of energy change that there is. Next one, D, if the car in C stops in 30 meters, calculate the force required to stop it. Okay, it says rearrange first, but you don't have to. Force times distance. So 10,000 is equal to the force we're trying to find times the distance of 30 meters. So something times 30 equals 10,000. So to find out what that is, we do 10,000 divided by 30 to find the force. So it's 10,000 divided by 30, and that will give you the force. And we always round, so it's 333 newtons. 4A, does a person do work when they hold a ball stationary 20 centimeters above a table? Does the ball gain any energy? So here's the person's arm, there's their cup, and there's the holding up a ball. Okay, so there's their fingers. There's the person's arm. It's a pretty strong guy. Okay, does this person do any work? Okay, well, does the ball go higher? No. Okay, does the ball go lower? No. So is there any distance traveled? No. Okay, so if we look at the formula work equals force times distance, We could be applying a force to the ball, but if the distance is 0, anything multiplied by 0 equals 0. So there is no work done on the ball. Does the person do any work? Well, we know that you get tired. So there's no work on ball. But we know that you get tired. So something is moving in the body. And in fact, what happens is your muscles will relax and then tighten up, relax, tighten up, relax, tighten up. And that will move the ball very slightly. So there will be some work done because you won't be able to do it perfectly. But if you had a crane, so imagine we replace you with something that could do the job better, which would be a crane, and it was holding the ball up, okay? Well, the crane can turn off. It doesn't need to do any work. It doesn't need an engine going to hold that there. There's no distance up, no distance down, so that the work done equals 0 joules. There's no work done on that ball, only if it's moving. Oh, and that's the next question. Does a crane do work when it's holding a 1,000 kg load 40 meters off the ground? No. The load is not moving. Okay, so in other words, you can just turn off the key and the crane will hold up the load. You see those cranes when they're finished, they'll hold up a flag or they'll hold up their hook. They don't need any energy to do that.